Hey everyone, quick question before we start. Have you ever written code that works today but break horrible tomorrow? Alright, so today we are finally starting design patterns, and in the last video we understood the core Java principles and things like why clean code matters, why loose coupling matters, and why design is more important than just syntax. Okay, so instead of wasting time and repeating theory, let's jump straight in. From today onwards we will focus on how world software is actually designed, and not just about how we are writing the code. Let's start first. So design patterns not about memorizing diagram, they are just thinking like a software engineer, not just a coder. Okay, and that's exactly what we are going to build from this video onwards. And my name is Shalu, and I welcome you to the most exciting video in the whole course, that is design patterns. So from this video onwards we will starting the design patterns, and in this video let's understand what design patterns really are. Design patterns are typically a proven solution to commonly occurring problem in software industry and software design. Let me explain this with a simple example. Suppose you want to build a house, and you don't just collect brick, cement and steel and start building randomly, right? So first you create a blueprint, and then you will create an architect design, and then blueprint to follow rules, standard and best practices. Okay, so all these things you need to do. If those rules are followed correctly, then chances of building are very strong, and building will be very high quality, and house are very high. Okay, so let's suppose if you don't have any blueprint, and what you just start building randomly, more likely things will go wrong during construction. Okay, so first you need to build architect for your house, and you need to make a design for your house. Same concept in software design as well. Similarly, when we are design code or law system, so especially in system design we also need a blueprint. Okay, so we understood well. That blueprint is called a design patterns. Okay, so let's understand what it will include inside the design patterns. Basically in this design pattern, so what we will do, like we will improve code structure, make code more maintainable. Okay, and make system more scalable, and we will reduce feature bug. Okay, whatever future bug we will have, and the cost as well we will reduce it. So they are not framework, they are not libraries, and they are ideas and best practices. Okay, so it's all about the best practice, whatever we are going to follow in the code level. So also we have a different categories of design pattern. Right now we are understanding the theoretical part. Let's understand the categories of design patterns at the high level. Like design patterns are divided into the three categories, like critical, we have like creational pattern, and we have a structural pattern, and we have behavioral pattern. Okay, so let's understand what they are categories like this. Okay, so right now we are understanding the theoretical part, we will understand the coding part in the next video. So let's understand the theoretical part only in today's videos. Let's understand creational design patterns. Creational design patterns means at the name suggests, like creational patterns deal with the object creation. In normal OOPs, like object oriented programming, how do we create an object? Like with the new keyword, right? Like we write like new and object, like new and animal, like this we create object, right? So it's simple, no? But in the real system, object creation can be expensive, and object creation can cause side effect as well, and object creation may need control. So conditional and the creational patterns provide better control and optimized way to create objects. Okay, they answer question like, let's suppose if I will have some question for you, the why should an object be created. I'll ask to you the question, why should an object be created, and then how many objects should exist, and how, like who control object creation. So all this will come inside the creational design patterns. Okay, so this is overall creational design patterns, and you can ask the question from yourself as well, like why should an object be created, and object should exist, and who control the object creation. Okay, so structural design patterns, like one object, we will understand the second was structural design patterns. So inside the structural design patterns, one object are created. So next question is like, if I'll ask, then I can ask it like, how do we connect them together, like creational and the structure as well. So structure patterns deal with the object composition and relationship between the objects, okay, and the building flexible structure. Okay, so this will come inside the structural design patterns. Next we will understand behavioral design patterns. Finally we decide like how should object behave and communicate. Okay, whenever we will create the object, then how we will understand like object behave and the communicate. So behavior pattern focus on algorithm, okay, and responsibility and object interaction. Okay, so house analogy, if we will understand, if we will revisit, then creational is like creation the house. If we are going to create a house, then we will keep the house creation inside the creational. Okay, wall and room layout we will keep inside the structure. Okay, and wiring, plumbing and interaction we will keep inside the behavior. So all these are design patterns that we have defined here, like creational, structure and behavior. We have understood well with the real example as well. Okay, let's understand with a real problem, like let's suppose in real problem with the coding, let's suppose we have a data connection problem. Okay, suppose we have a class called device like database services. Okay, the class connects to database, like the database we have like AWS, like we have cloud, etc. Okay, so has method to get and put the data. So we will create a class like database services, and inside the class we will create a method, a database services. That method will create an open DB connection. Okay, so this is the real problem of the DB. Okay, so every time whenever you will create a database connection, you have to create an object of the database connection. Okay, so a new database connection is open if you will create a class, a database connection. The problem is like, what if you create 100, like 1,000 object? If you create 1,000 object, you will open 1,000 database connection. This is the problem, no? So what it will impact, like it will create a high cost, and if we will face the performance issue, we will face the resource wastage. Okay, and also we will face the database connection limit, etc. Okay, so database charge per connection, this is very common in real system. Okay, if we will understand the desired behavior of this pattern is like only one database connection and reuse it everywhere. Okay, this should be desired behavior, what I'm telling you right now, and prevent user from creating multiple objects. Okay, so this is where Singleton design patterns comes in. So we will not create, let's suppose if we have like AWS, we have like Oracle, we have like SQL, so we will not create multiple object creation. We will not create 1,000 object, and we will create only one object with the Singleton patterns, and that's in this real problem we will have the Singleton design patterns we have. Okay, so what let's understand what is Singleton design pattern. So Singleton ensure that a class has only one instance and provide a global access point to that instance. Okay, so we will not create a multiple object, we will provide a solution with the Singleton patterns. Okay, we will understand what is the benefit of the Singleton patterns. Okay, so the first benefit is like, we will stop user from creating the object, make the constructor private. We will create a constructor and that should be private. So we will create a method like database services, and inside the database services we will call a database connection. Okay, so now user can't do like new database connection, we will not do like this. What we will do, we will create a single shared instance, and we will understand in the next video how we will create a single shared instance and also the singleton pattern. Right now we will understand theoretical part. So we will create the database services and the instance database services, and that should be static and the private as well. Okay, so and after then we will create the provide control access like database or services. We will create a static database services, and there we will check if instance equal to null, and then we will create a database services only one times. Okay, so we let's understand why this work. If we will create a singleton pattern, why this will work. So first call, in the first call the object is created. Okay, in the next call same object is returned with the singleton pattern, because this singleton pattern will run in the whole code. Globally it will call. So in the next call, the same whatever object you had created from the singleton pattern, that should be called in the whole class, and in the next call same object is returned. Okay, so no matter how many times you call the get instance we will write inside the singleton pattern, as I already told you. So only one database connection exists. But let's understand why actually happened internally. So user cannot create an object. Control class control object creation. Okay, first call initialize the object. Okay, and the subsequent calls reuse the same instance. Okay, so this is going internally. Okay, we will understand whatever I am telling you, like how it's going internally. When we will create the singleton pattern, when we will create a object with the singleton pattern, then what is actually happened. So I told you. Okay, so real world uses case of singletons like database connection pools. Okay, logger class we can create, configuration manager we can create, and the caching manager we can create. Okay, interview point of view, I need to give you some tips here. Like the problem, singleton is not always good. Okay, as I understood as a developer, it's not always good. So problem is here, why it's not always good, because difficult to test, mocking issue. We will face the mocking issue, and it will be very difficult to test the code. And we have a global state problem as well, and we will have like as we know, like we follow the multi-threading inside the Java, so we will have the multi-threading issue. And in multi-threading environment, basic singleton can break. We can face, if you will, let's suppose if you have created the singleton, if you created the object with the singleton pattern, then if you will get any null, then the whole global class will get the null. Okay, so this is the real problem. And advanced version if you will use, then it will be like synchronized and double checked. You can use a double check locking like enum singleton, which is very best in the Java. Inside the singleton pattern, we have also the lazy and the eager initialization. We can use the object created, and when needed we will add the lazy, and the object created at class load time we will use the eager. Okay, so it had its own use case. So inside this video, what we have understood, design patterns are blueprint for the software, and the singleton pattern is a creational design patterns, and it ensure only one object exist and useful for expensive resources, and must be used carefully. I am talking about the singleton pattern. Okay, so today we started design pattern. We started with the design patterns, and you saw how uncontrolled object creation can silently kill your system. And in the next video we will go even deeper and see how a small design today we can say month of refactoring tomorrow. Okay, so don't skip the next one, because this is where average code turns into the professional grade software. So see you in the next video, and until then, keep learning and keep building. Thank you.
We don't really know where the world is gonna go, but now everybody